of A all the way to the head of B, all the way to the head of B, and you call that vector C, that is the sum of A and B. That is the sum of A and B. And it should make sense if you think about it. Let's say these were displacement vectors. So A shows that you're being displaced this much in this direction. B shows that you're being displaced this much in this direction, so the length of B in that direction. And I were to say you have a displacement of A, and then you have a displacement of B. What is your total displacement? So you would have had to be shifted this far in this direction, and then you would be shifted this far in this direction. So the net amount that you've been shifted is this far in that direction. So that's why this would be the sum of those. Now we can use that same idea to break down any vector in two dimensions into its components, and I'll give you what that means in a second. So if I have vector A, let's call this vector X. Let's call this vector X. I can say that vector X is going to be the sum of this vector right here in green and this vector right here in red. Notice X starts at the tail of the green vector all the way to the head of the magenta vector, and the magenta vector starts at the head of the green vector and then finishes, where it finishes is where vector X finishes. And the reason why I do this, and this hopefully from this information right here says, okay, look, the green vector plus the magenta vector gives us this X vector. That should make sense. I put the head of the green vector to the tail of this magenta vector right over here. But the whole reason why I did this is if I can express X as the sum of these two vectors, it then breaks down X into its vertical component and its horizontal component. So I could call this the horizontal component, or I should say the vertical component, X vertical, and then I could call this over here, X horizontal. Or another way I can draw it, I can shift this X vertical. Remember, it doesn't matter where I draw it, as long as it's the same magnitude and direction, and I can draw it like this, X vertical. And so what you see is that you can express this vector X, as the sum of its horizontal and its vertical components. As the sum of its horizontal and its vertical components. And we're going to see over and over again that this is super powerful, because what it can do is it can turn a two-dimensional problem into two separate one-dimensional problems. One acting in a horizontal direction, one acting in a vertical direction. Now let's do it a little bit more mathematical. I've just been telling you about length and all of that. Let's actually break down. Let me just show you what this means to break down the components of a vector. So let's say that I have a vector that looks like this. I'll do my best to do. So let's say I have a vector that looks this. Its length is 5. So let me call this vector A. And I will say, so vector A's length is equal to 5. And let's say that its direction, we're going to give its direction by the angle between the direction it's pointing at and the positive x-axis. So maybe I'll draw an axis over here. So let's say that this right over here is the positive y-axis going in the vertical direction. This right over here is the positive x-axis going in the horizontal direction. And to specify this vector's direction, I will give this angle right over here. And I'm going to give a very peculiar angle, but I picked this for a specific reason, just so things work out neatly in the end. And I'm going to give it in degrees. It's 36.8699 degrees. So I'm picking that particular number for a particular reason. And what I want to do is I want to figure out this vector's horizontal and vertical component. So I want to break it down into something that's going straight up or down and something that's going straight right or left. So how do I do this? Well, one, I could just draw them visually, see what they look like. So its vertical component would look like this. Its vertical component would look like this, and its horizontal component would look like this. The horizontal component, the way I drew it, would start where vector vector A starts and go as far in the x direction as vector A's tip, but only in the x direction, and then you need to get back to the head of vector A, you need to have its vertical component. And we can sometimes call this, we can call the vertical component over here A sub y, so that it's y direction. We can call this horizontal component A sub x. And what I want to do is I want to figure out the magnitude of A sub y and A sub x. So how do we do that? Well, the way we drew this, I've essentially set up a right triangle for us. This is a right triangle. We know the length of this triangle, the length of this side, or the length of the hypotenuse. That's going to be the magnitude of vector A. And so the magnitude of vector A is equal to 5. We already knew that up here. So how do we figure out these sides? Well, we could use a little bit of basic trigonometry. If we know the angle and we know the hypotenuse, how do we figure out the opposite sides of the angle? This right here is the opposite side to the angle. We forgot some of our basic trigonometry, but we learn it right now. TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we have the angle, we want the opposite, and we have the hypotenuse. So we could say that the sine of our angle, the sine of 36.899 degrees is going to be equal to the opposite over the hypotenuse. The opposite side of the angle is the magnitude of our y component. It's going to be equal to the magnitude of our y component. The magnitude of our y component over the magnitude of the hypotenuse, over this length over here, which we know is going to be equal to 5. Or if you multiply both sides by 5, you get 5 sine of 36.899 degrees is equal to the magnitude, vertical component, the magnitude of the vertical component of our vector A. Now before I take out the calculator and figure out what this is, let me do the same thing for the horizontal component. Over here we know this side is adjacent to the angle, and we know the hypotenuse. And so cosine deals with adjacent and hypotenuse. So we know that the cosine of 36.899 degrees is equal to, cosine is adjacent over hypotenuse, is equal to the magnitude of our x component over the hypotenuse. The hypotenuse here has the magnitude